In this process, I'm using cyanide, so it's a deadly process. Do not do this at home, since cyanide is skin permeable. This is for demonstration only, and data in this video could be useful as a source for other methods of gold recovery. Let's scrap. It took about 4 hours to scrap 3 kilograms of cell phones. These are mostly old ones referring to the year 2006, which yielded 540 grams of PCB boards. I've also collected all gold-plated pins like SIM card and memory card pins in another batch. Other components like LCD flat ribbons, which contain some gold, been sorted. I did same to the cameras bases on the way of recovery, in this case burning cables and cameras. To start process, I added a stripper composition which I've made in previous video to 500 milliliters of distilled water, followed by addition of some sodium cyanide. I've talked about this stripper more specifically in previous video, so I just go through the process. When sodium cyanide completely been dissolved, I thought it might be good idea to test this solution over one of those PCBs. And when I found gold leaching proceeding was successful, I added more PCBs. One of those cell phones, which was N95 Nokia, had gold plating, even our camera casing. I prepared another batch of stripping with different concentration of components to experiment leaching ability. Also, this model of old HTC smartphone had high quality gold plating on the PCB and mic either. Just some patches remain undissolved in points covered with some kind of resin. When leaching process of all PCBs done, I prepared another batch to process pins. I let pins sit for 1 hour just in case to not lose any trace of gold. Afterwards, all gold containing solution filtered. Solution volume remarkably increased due to the preparation of some experimental batches. I heated solution to increase reactivity with zinc powder. Then I started adding excess sodium hydroxide, about 120 grams, to prepare solution for addition of zinc powder. Zinc powder added, and I let it sit for several hours to catch all gold with occasional stirring. After several hours, solution been decanted and some nitric acid added to dissolve zinc and other possible metals to leave gold behind. The reason I've used nitric acid is that it's able to dissolve various kind of metals. I noticed kinda resistant deep blue color. It seems it is colloidal gold released from zinc surface after treating with acid. To prevent gold losing, I decided to add a few drops of bleach to dissolve colloidal gold. Since in gold stripping composition I've used MBT or mercaptobenzothiazole as an inhibitor in order to prevent copper dissolution, After acidifying solution with nitric acid, some mud will form if zinc powder wasn't washed properly. That's why I decided to filter solution. When I decided to drop gold, I realized what a disaster I was facing with. Gold will not drop in this high volume of nitric acid and bleach mix, even after addition of SMB and iron sulfate. To fix that, I found only one way, which was treating solution with some copper to react with excess nitric acid, followed by addition of sulfonic acid to remove last bit of nitric acid. Gold solution turned deep green after contaminating with copper, but I succeed to drop gold. Next day I checked cyanide waste. There was some black precipitate at the bottom, which could be potentially gold and zinc. I found it good idea to treat it with hydrochloric acid this time instead of nitric acid. After decanting, black residue treated with hydrochloric acid and remaining powder redissolved with some drops of bleach and then filtered. This batch was much easier to recover than nitric acid batch. Since nitric acid batch was contaminated with copper, it was necessary to be refined, and gold redissolved with some bleach and hydrochloric acid and vacuum filtration carried out. Afterwards, filtrate transferred to a beaker and SMB added to drop gold. Then gold powder been boiled off. This helps to fine powder stick together and be accumulated much easier. Gold powder washed a few times with water and filtered through a filter paper, then some sodium carbonate and borax added to start melting process.
Let's weight this yellowed gold piece to see the result. It's about 140 milligrams of gold or 0.14 grams of gold we have here. Let's have a small talk about this composition. I've used cyanide in this process. I should warn again, do not do this at home. A few milligrams of cyanide could potentially kill an adult person. In following, I've used MBT, cyanide and metanitrobenzoic acid. Metanitrobenzoic acid was pretty good oxidizing agent, didn't kill any cyanide, but it is kinda hard to make this chemical. So I think it is good to be substituted with hydrogen peroxide while keeping cyanide and MBT. MBT will prevent and inhibit the solution of copper and slightly reduce attacking bright nickel underneath the gold plating, but it will not prevent the solution of iron. So you shouldn't use any iron piece in the bath that you want to leach gold. But while using hydrogen peroxide as an oxidizing agent, it is very prone to kill cyanide since it is not as mild as a metanitrobenzoic acid. So you should just keep adding more cyanide to keep dissolving gold. Okay, I think it is done, and that was the conclusion for this composition which I have made. In the next project I will process IC chips from cell phone boards to see how much gold I would get from IC chips. And here you can see this is copper. which means MBT was great to inhibit the solution of copper into the cyanide bath. Okay, we are done, and this was our result making gold stripping solution. Hope you enjoyed. Until next project, see you next time.